Today we're taking a look at Task 8, what comes next and what comes later. This is a practice understanding task. The purpose of this task is to practice writing recursive and explicit formulas for arithmetic and geometric sequences from the table. This task also provides practice in using tables to identify when the sequence is arithmetic, geometric, or neither. It will extend your experience with sequences to include geometric sequences with alternating signs and more work with fractions and decimal numbers. The essential question is, how can we efficiently use the information in a table to write formulas for arithmetic and geometric sequences? In our previous tasks, we've explored arithmetic and geometric sequences. We have learned what the tables, graphs, and equations of each of these sequences looks like and the general behavior of the pattern. While working on this task, ask yourself, what strategies do you use or are you working on to help write formulas for arithmetic and geometric sequences? Let's jump in. For each of the following tables, we're going to describe how to find the next term in the sequence. We're going to write a recursive rule for the function. Describe how the features identified in the recursive rule can be used to write an explicit rule for the function. Write the explicit rule for the function, and then identify if the function is arithmetic, geometric, or neither. Let's look at our example. We have a table with x and y that goes 0, 5, 1, 8, 2, 11, 3, 14. Our description is, to find the next term, we add 3 to the previous term. That helps us write our recursive rule. We start with 5. Our current term is equal to our previous term plus 3. To find the nth term, we start with 5 and add 3 each time. Notice how our recursive rule and our description of finding the nth term work together. We start with 5 and we add 3 n times. We can see that in our recursive rule, starting with 5 and adding 3 to each output every time. This leads us into our explicit rule, f of n is equal to 5 plus 3n. And then we notice, is this arithmetic, geometric, or neither? Since this sequence is adding 3 every time, it's arithmetic. Let's look at function a together. First, we want to describe how to find the next term. Looking at my table, I notice I have 1, 5, 2, 10, 3, 20, and 4, 40. Well, to get from 5 to 10, I could add 5. To get from 10 to 20, I can't add 5. So I don't have a repeating rate. Let's think about what else I could do to 5 to get to 10. I could multiply by 2. To get from 10 to 20, I can multiply by 2. And to get from 20 to 40, I can multiply by 2. So when I'm finding the next term, I multiply the previous term by 2. I could also write this as double the previous output. Now I'm going to work on writing my recursive rule. I notice I start with 5, so f of 1 is equal to 5. And then f of n, that's my current output, is equal to my previous output, f of n minus 1, times 2. Now I need to think about how to find the nth term. To help me find the nth term, I'm going to make an expanded table. I'm going to look at the relationship between x and y for 1, 2, 3, and 4. And create a little more space. 1 is 5, 2 is 10, 3 is 20, and 4 is 40. Well, I know that I can get to 5 by saying 5 times 1. I can get to 10 by saying 5 times 2. I can get to 20 by saying 5 times 4. And I can get to 40 by saying 5 times 8. Notice we always started with 5. I know that my rate is 2. So I'm going to try to rewrite 2, 4, and 8 in terms of 2. I'll do the same with 1. This is 5 times 2 to the 0 power. Any number to the 0 power is 1. This is 5 times 2 to the first power. 4 can be written as 2 squared. So this is 5 times 2 to the second power. And 8 can be written as 2 to the third power. So 40 is equal to 5 times 2 to the third power. Now I need to notice the relationship between my exponent and my x term. Notice here my exponent is 2 and my x term is 3. So this is 5 times 2 to the power of x minus 1. Looking at our second term, my exponent is 1 and my x term is 2. So this can also be written as 5 times 2 to the power of x minus 1. This is also true for when x is 1 and when x is 4. To explain this in words, I start with 5 and multiply by 2 to the power of x minus 1. This description helps us write our explicit rule. F of n is equal to 5 times 2 to the power of x minus 1. Since I'm multiplying each previous output by 2, I have a constant ratio, which makes this a geometric sequence. Your task today is to work on the other functions on your own or with your small groups.